All right, so are you trying to figure out how exactly to name some compounds? Right? Are you not sure how to name a molecular versus an ionic compound? Well, let's talk about it. Let's talk about it today. All right, so let's get into this very first thing that I have to cover, which is nomenclature. Right? Nomenclature is a term that we use when we're talking about naming compounds. So essentially, the definition of nomenclature is just choosing names for things. So when we're talking about chemistry nomenclature, we're talking about how they chose the name for those chemicals. So the reason why nomenclature is so important, right, is because when we think about just overall the big world, you got people over in Japan, you got people over in Africa, you got people over in Europe, and you got people over in US, India, everywhere in the whole world doing chemistry. All right. So what happens when somebody over in Japan, right, founds a chemical? How should they name it? All right. They can name it in any old way. However, because we have this nomenclature system, there is a set way we have to name things now. For example, here's a great example when we're thinking about laughing gas. So when we first, right, when they first found, these different chemicals, especially back in the day in the 1700s, 1800s, everybody was just naming anything, right? Laughing gas is one of those. Milk of magnesia is one of those, right? There was really no set type of form, right? If I was looking at, well, what is laughing gas? I would not know what laughing gas is, right? I just know that by the description, right, it's probably gonna make me laugh, right? Got that gas, you know what I'm saying? So it's gonna make me laugh. But I wouldn't know the actual chemical, right, formula, right, or even the idea of what is inside laughing gas. So that's the reason why they came up with this nomenclature system in chemistry. So, for example, when we're thinking about laughing gas, the real chemical formula, right, is nitrous oxide, right, N2O, right? That is laughing gas. Now, right, my friend over in Japan, if I say, hey, I got nitrous oxide, he knows exactly what that is because it's the same nomenclature. So that's the reason why nomenclature is so important, and you got to know this when you're dealing with this chemistry or type of stuff. So when it comes to actually naming the compounds, I always get the question like, well, how do I start, right? How do I even start to name a compound? Well, there's two things that you could do here. Okay. The first thing that you need to do, first thing you need to do is you got to figure out if this is a ionic bond or a covalent bond. That's essentially it. So depending on the type of bond, that's going to impact the type of compound you have. So to give this away quickly, ionic bonds have one metal and one nonmetal. Covalent bonds have two nonmetals. Right, so the bonds will influence the name. Once again, ionic bonds have one metal and nonmetal elements. Covalent bonds have two nonmetal elements. That's essentially it. Okay. So, well, Dr. J, how do you know if it's a metal or non-metal? Okay, great question. Let's talk about it. So, here is a great, as far as little table for y'all to look at. Essentially, all we need to understand is that you see this little blue area right here. So this blue area, the metalloids, right? The metalloids right here, this little area. Basically, from this area and towards the left, we consider everything towards the left. So that's my blues, that's my greens, right? These are my yellows, my oranges and reds. All of this, except for hydrogen, so all of these are what we consider to be metals. All right, every single one of these. Now, towards the right of my blue, right, these are all nonmetals. So what we are going to find out is that many? It's not that many nonmetals. All right, it's really not. Majority of the periodic table is made up of metals. Okay. So that makes it easier for us to distinguish between nonmetals and metals, right? Once again, these are my nonmetals. These are my metals. Now, a couple of different things that is very important that I would suggest you all looking at a couple of my old videos is understanding the different groups, all right, or families, okay? So I'm going to briefly go over this, but like I said, if y'all want like further detail as far as the different types of groups, I got a video about that already. All right, but looking at this chart, This is what you want to memorize from this chart. This is going to be very, very, very helpful. Okay. So once you figure out if it's a metal or non-metal, you need to figure out the charge, okay, of that element. Once again, once you figure out if it's a metal or non-metal, you need to figure out the overall charge, or the technical word for that is the oxidation state of that element. So what we find out is that every single element on the periodic table has a oxidation state. All right. So basically that means a charge. They have this type of charge because when they form these ions, that's when they get their charge, right? They're either going to lose or gain an electron. Once again, that's basically it summed up real fast. If you want more information about ionic compounds specifically, please check out my old video about that. But essentially, an ionic compound, we got the losing or gaining of electrons. That's basically what it is if y'all don't feel like looking at the old video. So with that being said, let's look at the charges. So if we look over here, we have our plus ones, plus two, plus 3, minus 2, minus 1. Essentially, each one of these columns means that in this case, this entire first column has a plus 1 charge. This entire second column has a plus 2 charge. This entire column right here has a plus 3 charge. This entire column right here has a minus 3 charge. And this entire column right here has a minus 2 charge. And then lastly, this entire column has a minus 1 charge. Essentially, if y'all remember these main groups, as far as the charges, y'all are going to be very, very fine when it comes to naming these compounds. Now, one thing I will mention here, notice that this big bulk of metals right here. This big bulk of metals is what we call transition metals. Transition metals can have one, or in this case, most of the time, they're either going to have 2, 3, or more different types of charges. All right, that's essentially what we need to understand about transition metals. So because of this, we're going to have to figure out the charges of these transition metals. Please stay with me, please wait. You know what I'm saying, before they just blows your mind. Okay, but once again, we know the charges of these, therefore we're going to have to figure out the transition metals. Okay, that's essentially it. We know the charge of these. And now that we know the charge of these, we can figure out the transition metals. Hold on, we're going to do some examples at the very end here. But once again, the key thing that y'all need to understand is that you are going to have to know if it's a non-metal or a metal, and then you're going to need to understand the charges for that non-metal or metal. And basically, if you memorize 1, 2, jump over to 3, then we got minus 3, minus 2, minus 1. You're good to go. All right. If you are not able to understand, right, or if you don't have a type of periodic table like this, essentially, if y'all see this 1A right here, this means that I got a plus 1. 2A means I got a plus 2. 3A means I got a plus 3. 5A in this case is minus 3. 6A is minus 2. 7A is minus 1, okay? Just to reiterate that. Let's go forward. So let's look at an example. I want to look at an example here. So ionic compounds, all right? Ionic compounds. So break this down, okay? So to break this down, essentially, when it comes to naming compounds, we're going to follow these type of rules here. So this is how I'm going to break down this ionic compound. So we got salt, y'all. We got salt. In case you didn't know, this is salt. Let's talk about how salt gets its name. So salt is made up of sodium and chlorine. Once again, salt is made up of sodium and chlorine. So we can see this in the chemical formula here, NaCl. NaCl. Now understand, I'm talking about ionic compounds. Here's the key thing about ionic compounds, y'all, is that ionic compounds are ions. Okay, that's the key thing that you got to realize. Ionic compounds are ions. So when we're thinking about ionic compounds, right, we're thinking about the ions of these elements. So when I think about sodium, I'm thinking about the sodium ion. When I think about chlorine, I'm thinking about the chlorine ion. Okay, so once again, how do we get to the ultimate name here, though, based on the formula? So if I'm trying to name this compound right here, if I see NaCl, the first thing I need to realize is that, okay, all right, do I have a ionic or molecular bond here? All right. So remember, ionic compounds have a metal and a non-metal. So I see sodium and I see chlorine. In this case, sodium is going to be a metal, chlorine is a non-metal. How do we know that, Dr. J? Let's go back here. All right, if I look over here, sodium, if we look right here, this is where sodium is located, right? Proton number 11. Okay, we just mentioned that anything towards the left of this blue, right, is basically all metals. So in this case, sodium is going to be my metal. What about chlorine? Anything towards the right of my blue over here, we look at chlorine, right, at number 17, this is a non-metal. So right off the bat, the first thing y'all need to do is look at y'all periodic table if you don't have these memorized off the top of your head. All right. So I got sodium, my metal. I got chlorine, my non-metal. Because I have those two, that means that I have a what? Ionic compound. All right. I have an ionic compound here. So now that I realize, okay, I got an ionic compound, how should I name this actual ionic compound? So what are we going to have to do here? We got to follow some certain rules when it comes to naming ionic compounds. So in this instance, when you go to name an ionic compound, the first thing you want to do is put your cation first. So for those of y'all who don't know what a cation is basically an ion with a positive charge. All right, to sum that up quickly, it is an ion with a positive charge. So you put your cation first. In this case, it's going to be the metal. Metals are always going to be cations, right? Now, next, we have our metal, right? Our cations first, and then second is our anions. So anions are negatively charged ions. So in this case, our chlorines are going to be our negative ion in this case. So once again, cations first, anions second, anytime that we're dealing with ionic compounds. So let's talk about how we're ultimately going to name this ionic compound and salt. So we're going to put the cation first. Like I just mentioned, cation goes first. So in this case, the cation is sodium. So we're going to put sodium first here. All right. So now that we got sodium first here, all right, what comes second? The anion. So in this case, the anion we said was chlorine. All right, chlorine comes second. So we got our cation first, anion second. Now, that's the order you need to understand for ionic compounds. Cation first, the metal, anion second, the non-metal. So once we have the order correct, this is the second thing you need to do when it comes to naming these ionic compounds. So, right, we have sodium and chlorine. For all of my anions, we need to change the ending, right, to IDE. So instead of this being chlorine, right, CHLORINE, we change the ending of my chlorine to IDE. We do this every single time with every single type of ionic compound. You will always change the ending of your anion to IDE. So in this instance, when we're talking about salt, right, salt is sodium chloride. So basically, right, once again, how do we determine this? All right, let's do a little quick review. Sodium, chlorine. I realize that sodium is a metal. I realize that chlorine is a non-metal. I have an ionic compound. I also understand because sodium is a metal, that means that is a cation, right? It's a cation. If you don't remember, cations like to lose electrons, okay? So sodium loses electrons. That's how it becomes this positive charge. Chlorine is our anion. If you remember about anions, they like to gain electrons. This is how we see our negative charge over here, okay? And if you don't remember none of that, just go to the periodic table. Look at where sodium is. We're going to see it's a +1. Look at where chlorine is. It's a -1. All right. So Now, once we get that metal and non-metal, we then just need to translate it to the actual words. Sodium, we keep the first cation the same. You do not touch that. It's always going to be sodium. And then the only thing that we do touch and change is the anion. We change that ending from chlorine to chloride. All right. Shout out to Flowrider. I don't know why I just thought about that, but shout out to, I'll say the rider. Apple bottom jeans. Okay. So let's look at a more complex example. Okay. So the first example, right, was sodium chloride, which is, in this case, I like to think of these as the simple main group elements. But what happens, right, when we have to give an ionic compound using one of these transition metals? So if you have a transition metal, right, and a non-metal, you got to understand we have an ionic compound. But if you do have a transition metal, understand that naming it, you're going to have to do a couple different things, okay? So let's look at this example right here. We got CrBr3. CrBr3. So we understand, right, as the title says, it's an ionic compound. How's it ionic compound again, Dr. J? Because Cr is a metal, Br is a non-metal. Now, wait a minute. Where is Cr on my periodic table? Cr is located in this first row right here. And once again, what do we notice about this? It's in yellow. So that means that this is a transition metal. Now, in this case, right, Cr, if we look very closely, Cr can have multiple charges, right? That's what I mentioned with the transition metals, right? If we see here, Cr can have two of those right there in that case, all right? So we can have either this one or that type of charge. How do we decide which charge to use, all right? So this is what I do not suggest. I don't suggest you printing off one of these and then just trying to memorize every single charge of the element. That is crazy. I don't even do that, right? I don't do that. So why would you do that? So this is what I suggest you do if you have a transition metal and an anion when it comes to naming your compounds. So what are you going to have to do here? So the first thing here is, let's talk about a couple of different things. So understand what ionic compounds is that. With ionic compounds, all of my basically compounds need to be neutral. So what do I mean by neutral? In this case, we need to balance, right? We need to balance our actual chemical formula. All right, so in this case, when I mean balance, it needs to equal 0, all right? So let's talk about this. Let's talk about this a little bit more. So bromine, we understand that bromine is my anion. I also understand in this case, CrBr3 means that I have 3 bromines, and I have 1 chromium in this case. So because I have 3 bromines, right, if we look over here, I have 3 bromines. So I have 3 bromines going around in this case, when we're thinking about ionic compounds, right, I got my 3 bromines in my ionic compound. So if I add up all 3 of my bromines, I have an overall charge of -3. Okay, so in this case, we got to think here as far as our math, right? We have to do a little bit thinking with math. So I have 3 bromines. And also understand this is a neutral compound. Now, one way to know that you have a neutral compound is that you don't have any type of number in the top right-hand corner. So if you have a number in the top right-hand corner of your compound, that is letting, right, you and me know that there is a charge associated with this compound. So if I saw a +1, that means that this compound has an overall charge of +1. So for instance, if that was a +1 instead of 0, right, for neutral compounds, it would be a +1 here. But because I don't have a number in my top right-hand corner, that means that this is just an overall neutral compound. So because it's a neutral compound, I understand that both my chromium and my bromines need to balance each other out. Okay. So right now, how am I going to balance my 3 bromines? In this case, I have my 3 bromines. I have an overall charge of -3, and this is a neutral compound once again, so it needs to equal 0. Okay, that's the thing that we need to understand. Before we go even further, we need to understand that. So I got -3 equals to 0. Now, what can I do to balance, right, this overall formula, right? How can I balance -3? What do I need? So in this case, I need a 3, right? Because if I have +3 and a -3, that's going to give me a 0, right? 3 minus 3 is 0. So what does that mean, Dr. J? Well, that means that my chromium has to be chromium 3. So that is the charge of my chromium, right? Basically, right, I had to figure out my anion before I could figure out my cation. And that's what I suggest you all do when it comes to naming ionic compounds. Figure out your anions first, then, okay, let's figure out this crazy transition metal, right? Because we understand, okay, I can have one charge or I can have another charge, right? So in this case, we have to do some problem solving, right? That's what chemistry is. We have to problem solve, right? So once I figure out that my charge for my chromium is a 3, right, that's going to help me name this compound because now I know the charge of my chromium. So that was a lot. I just had to, that was a lot, y'all. I just, when it comes to the transition metals and naming the ionic compounds, it's a whole lot. But once again, we got our chromium. We understand that this is +3. Bromine, we understand that bromines are -1 because they're a halogen, right? They're in that type of group. As well, they're a non-metal, okay? And we have 3 of those. So we got a -3. Got to be neutral. So that means that my chromium must be a +3, okay? If everybody understand me so far, right? If you don't understand me, please let me know in the comments. Now let's talk about naming this compound. So this is an ionic compound. So it's the same thing, right? It's the same exact thing. You need your cation first, your anion second. Always going to be the same. And in this case, your cation is first. You keep that the same. You don't even mess with it. Your anion is the thing that you're going to mess with. In this case, we're going to change that ending to IDE. Okay. Now, here's a new step. Because we have a transition metal, right? My boy over in Japan, if I tell him that, okay, bet I got this certain compound, I got to let him know, okay, if I got a transition metal, well, what is the charge, right? Because we just said that chromium has 2 charges. Which charge is it for this compound? That is where this Roman numeral will come in place here. So if y'all remember Roman numerals, all right, you got your 1. That's the one where it's like 1, 2. You got L, you know what I'm saying? V, C, those, all right? I could do a quick review over those, but essentially, right, it's very simple. We're not going to get to L or C, because that's 50 or 100, you know what I'm saying? We're not getting that high. But essentially, you should know your Roman numerals, probably up to 7 or 9 for some instances, but, that the 10 and less, you'll be fine in chemistry, okay? So let's talk about that. So we have to use Roman numerals to dictate the actual charge of your metal. So once again, we use Roman numerals to help us figure out the charge of our metal. Once again, we use Roman numerals to tell the charge of the metal. So this Roman numeral will never tell the charge of your anion, right? The reason being is because most of the time we already know the charge of the anions. So now let's talk about naming this compound finally, all right? So what am I going to do here with this CrBr3? It's a cation, chromium. In this case, chromium goes first. Stays the same. You don't even change it. Very simple. Now, here's the next step, and here's a new step for the transition metals, right? The yellows. So in this case, We did all this work beforehand, right? It was not just for a waste. It was for a reason. There was a reason. We had to determine the actual charge of my chromium. In this case, we determined that the charge of the chromium is 3, right? Because 3 minus 3 gives us 0. It's a neutral compound. So because the charge of chromium is 3, I'm going to use Roman numerals to let the people know that this chromium has a charge of 3. So when it comes to writing out the name, it looks like this: chromium 3, right? So this is telling me, okay, first off, chromium is my cation because it's first. Second off, this is telling me that, okay, this is a Roman numeral. I understand I got a transition metal here. Third off, right, this is telling me, okay, I got 3. So this means that my chromium has a charge or oxidation state, right, of 3. That's what this lets me know. Okay, bam. That's the first part. Second part is what we already know, right, what we just described. Your anion is second. So your anion is bromine. I'm going to change, once again, the ending of my anion to IDE. Once again, I changed bromine to bromide. Bromine to bromide. Once again, bromine to bromide. Okay, I had to do it 3 times for the chromium. So, all that being said, the name of this compound from the chemical formula of CrBr3 is chromium 3 bromide. Okay. If y'all don't understand, yo, let me know in the comments. Let me know. Let's move on. And let's talk about molecular compounds. So molecular compounds, very, 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 very simple as far as much, much easier to understand than my boys at the ionic compounds. All right. So molecular compounds. Let's just look at an example. Ni3. So what's the first thing that you should always do in this case? First thing that you're going to do when it comes to naming compounds, y'all, is that you have to determine the type of bond. So we just mentioned, right, we have ionic bonds versus covalent bonds, right? Now, with covalent bonds is going to occur, right, between 2 nonmetals. Nitrogen and iodine are 2 nonmetals. How do we know that they're 2 nonmetals? Let's go. Let's go back to my chart. There we go. 2 nonmetals. Where's nitrogen at, y'all? Right here. It's towards the right of my metalloids, my blue people right here. So if it's towards the right on this periodic table, in this case, it's going to be a nonmetal. Now, where's my I's at? Bam, right there. My I, is it towards the right of my blues, my metalloids? Yes, it is. So it's a nonmetal. That's the first crucial thing you should always do, y'all, is to figure out whether, right, it's a ionic compound or molecular compound, right? So that's the first thing you do. In this case, y'all probably already knew that because molecular compounds is the title here. All right, so we got a molecular compound. Great. How do we name molecular compounds? Well, it's very, 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 very similar to how we name ionic compounds. So the first element in this case is going to be the full name. The second element is what we're going to be changing the ending to IDE. Does not sound the same as naming ionic compounds. Because, right, if we think about ionic compounds, your cation, which is the first element, stays the same, the full name. And then our anion, the second element, changes it, right, to IDE. So notice the structure is basically the same. So in this case, we got 2 nonmetals. Now, here's the thing that's going to be different from ionic compounds. We got to use prefixes in this case. So the prefixes tells me how many elements I have. So now that we're using prefixes, guess what, y'all? I don't have to balance anything no more. So I don't got to do any math this time, right? No type of math. I don't got to do no algebra and figure out, okay, if I got 3 bromines, how many chromiums should I have? I don't have to do any of that. All I have to do is use the correct prefix to let me know, okay, how many elements do I actually have here? So let's look here, right? Let's look. Ni3. Ni3. So understand that I got nitrogen, iodine. The first element is a full name. In this case, nitrogen is going to be my first element. So let's put nitrogen first here, right? Nitrogen. So now that we know that nitrogen is going to be first, great. What about the second element? What are we going to do here? Second element I mentioned is iodine. So I know I immediately need to change the iodine to iodide. That's what we see here. I changed the iodine to iodide. Bam. Good to go. Now here's the new and most critical thing is that I have to change my, right? In this case, I need to add my prefixes. So let's talk about this. I need to add my prefix to let me know that I have three iodines. So the prefixes that we're going to be using, right? Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All right. Know the basic 10, the first 10. Just know the first 10. But in this case, 3, I understand is tri. So what am I going to do for my prefix? I'm just going to put tri in front of my iodide. So now my final molecular compound name is nitrogen triiodide. Once again, the nitrogen is the first element. It's going to stay the same. I didn't change a thing, okay? Second element, iodine. I do have to change the "ine" to IDE for "ide." As well as I need to add my prefix to let my boy know over in Japan that I got 3 iodines in this type of chemical. So I'm going to put a tri in front of my triiodide. So we have nitrogen triiodide as our final name of this compound here. And once again, I didn't have to balance anything because the prefixes told me what how many we actually had in this case. Okay. So let's talk about, once again, those prefixes. I just want to show you a couple of examples of this one. So one thing that I will state right here, right? Mono, that means one. For instance, if we got NO, this is the nitrogen monoxide is the name of NO. Now, question. I have a question. Dr. J, why is it not mono nitrogen monoxide? Well, the reason why it's not mono nitrogen monoxide is because it's redundant. Okay, that's basically it, right? There's no need to put mono nitrogen first. The reason being, right, it's going to be implied that if you're just saying nitrogen and it's the first element, it's just one. It's just one. Now, if you got 2 or 3 for your first element, that's a different story. We want to get there. Let's look at the second one, di, NO2. NO2, we have nitrogen. Once again, we didn't put mono nitrogen, it's just nitrogen. And then for the second one, we have 2 oxygens. So what do we need to do? I need to say di. That's letting the people know that I have 2 oxygens. As well as, what do I do as well? I change the ending of my second element to IDE, right? It's the same thing over and over again, all right? Let's look at tri, all right? Tri, N2O3. Notice this time, right, I have 2 nitrogens for my first element, so I need to let the people know, okay, I got 2 nitrogens. So I need to say di-nitrogen. Once again, I put di because there's 2 nitrogens. Nitrogen stays the same because it's still the first element. The 2, this is just letting the people know there's 2 nitrogens, y'all. All right, second element, oxygen, we got oxide, changing that oxygen to oxide, and then letting the people know that there's 3 of them, so we have trioxide. And this is the same format for all of these, from 4 to 10, right? Tetra. All right, but everybody, that is essentially it for nomenclature. Now, there's one thing I will mention. You need to know your polyatomic ions. If y'all want to learn about polyatomic ions, just let me know in the comments. Definitely do a video over that. But I've already got a video over polyatomic ions, but if y'all want to see another one, please let me know. Thanks for listening to this episode of Don't Be Scared. We hope you found this discussion valuable, helpful, and informative. You can reach us through our website, social media, or by leaving a review on your favorite podcast platform. 5 stars, y'all. And don't forget to check out our resources and services at Don't Be Scared, where we help organizations and individuals engage with science and pursue their dreams in the field.